Now next part is application of matrices. Application of matrices. In application of matrices, equations are given and you have to find the value of x, y or x, y and z. Means how we solve the equation simultaneously we used to get the values of x, y and y or z. And here by using matrices you have to find the value of x, y and z. So there are two methods in application of matrices, that is inversion method and reduction method. So first we will see the inversion method. So using matrices you have to find the value of x and y. If 2 by 2 matrix is there, then x and y. If 3 by 3 matrix is there, then x, y and z. So here in inversion method, see how is the method. Ax is equal to b, means by using equations we will write the matrix A and B. So in the form you have to write Ax is equal to B pre-multiplying by inverse, means before you have to multiply by A inverse. So A inverse A into x is equal to A inverse B. A inverse A is I, so Ix is equal to A inverse B and x is equal to A inverse of B. So this is the formula for inversion method. Now see here, this x means values of x, y or x, y, z. Here we are having matrix A. Of that you have to find A inverse and then B. So A inverse into B if you do, you will get the values of x, y and z. Now this A inverse, here you have to find the A inverse in the formula. This A inverse you can find by row transformation or by adjoint method. Which method you feel easy, by that method you can find the A inverse. So we will find the A inverse by adjoint method only. So it is easy. So here how to write the matrix AC. Now here matrix A we will write. See here coefficient 1, 2, 2, 3. That is the matrix A. Matrix B is 2, 3 and x is x, y. Now our same form you have to repeat here again. Ax is equal to B. Right in that form. A is this matrix, x means xy and B matrix. Now what is our method for inversion? Pre-multiplying by A inverse. Same we have to write here. In each and every sum you have to, by inversion method you are doing this A inverse, pre-multiplying by A inverse you have to write. A inverse into A into x is equal to A inverse B. X is equal to A inverse B, therefore x is equal to A inverse B. Now we got formula for x, so here we have to find A inverse. B already we are having. So how to find A inverse? Now A inverse we can find by any method which you want, but easy method, if you feel easy, adjoint method you can find by the adjoint method. Now see, we will find A inverse by the adjoint method. So first write down the matrix A, 1, 2, 2, 3. Then what is our first step? That write the determinant of A and see that it is not equal to 0, then only A inverse exists. So write down determinant of A, it becomes -1, which is not equal to 0, therefore write down A inverse exists. Now for by adjoint method, what is the formula? A inverse is equal to 1 upon determinant of A into determinant of A into adjoint of A. So here you have to find the adjoint of A. To find adjoint of A, we want cofactor. So first we will find the cofactor. So first we will write minor. Minor of this M11 is, leave this row, this column, means what remains? 3. And A11 is equal to minus 1 raised to I plus j, means 1 plus 1 into this 3 is equal to, means this is positive, 1 into 3 is 3. Now minor of this row will go, this column will go. So what remains? 2. A12 is equal to minus 1 raised to I plus j, means 1 plus 2 and into this minor. So it becomes, this is odd, so it becomes minus. In the same way, if you want to find the minor of this column and this row will come, it will become 2 and its adjoint is -2 because this is odd. And minor of this is this row and this column will go, that is 1, and its cofactor is minus 1 raised to 2 plus 2, which is even, so it will be plus 1. 1 into 1 is equal to 1. Now we will write its cofactor. Cofactor matrix means 3 minus 2 minus 2 1. Its adjoint is, take its transpose, means 3 minus 2 will become column and minus 2 will become column. Now write down the formula. Formula is A inverse is equal to 1 upon determinant of A into this adjoint of A. So here you write the formula. I have written directly. A inverse is equal to 1 upon determinant of A into adjoint of A. Now this minus will multiply and take inside, so it will become minus this minus 3. So here A inverse is equal to minus 3 2 2 minus 1. Now we got A inverse value. So what is our x? X is equal to A inverse into B. So we know inverse. We got A inverse 3 minus 3 2 2 minus 1, and B is 2 3. Our B matrix which is given is 2 3. Now you have to multiply this two matrices. You know how to multiply. The order of this is 2 by 2 and order of this is 2 by 1. So this and this is same. So our new matrix, after multiplication, the order of the matrix will be 2 by 1. See, first write down the order, then you multiply. So here 2 rows and 1 column will go. So row into column, row into column. So minus 3 into 2 minus 6, 2 into 3 is 6. Now this second row, say 2 into 2 is 4, minus 1 into 3 is minus 3. So minus 6 plus 6 0 and 4 minus 3 is 1. What is our x? Matrix xy. Therefore equate its value. So x is equal to 0 and y is equal to 1. So you can substitute in if you want to verify, substitute in any one of the equation and see the equation is satisfied or no. Now this was the 2 by 2 matrix. Now we will solve 3 by 3 matrix, means 3 equations, means finding value of x, y, z. Finding the value of x, y, z by same method, inversion method only. So here see third sum. Here 3 equations are given. So first we will write matrix A. Matrix A is 2 minus 1 1 1 2 3 3 1 minus 4. This is, and x means x y z and b means 1 8 1. Now we will write ax is equal, this is a x b, ax is equal to b. So what I told, in inversion method, this you have to compulsory you have to write this. Remember, in inversion method, first you have to write ax is equal to b and multiplying by a inverse. A inverse into a into x is equal to a inverse b. This is ix is equal to a inverse b. So we got the formula x is equal to a inverse b. If you know x formula, then also this you have to write compulsory. Now we will find, we know b and we want to find a inverse. So a inverse by any method you can find. Here again we will do the adjoint method. If you do adjoint method properly, it will not go wrong. By stepwise if you go, the answer will not become wrong. So first we will find matrices. We will find a determinant. So write in the determinant form, find the value of the determinant, and that determinant value is coming minus 40, which is not equal to 0. Therefore A inverse exists. So A inverse exists, then write down matrix A. Now we will find its cofactors. So for that, how we will find the cofactors? So first we will write its minor. For 3 by 3 matrix, how to find the minor? So suppose we want to find the minor of this 2. This row and this column will delete, and what you will write? 2 3 1 minus 4. Okay, so solve this matrix, you will get minus 11. Then A11 cofactor is equal to minus 1 raised to I plus j into minor minus 11. This is 1 into minus 11 is equal to minus 11. Now minor of this minus 1 is equal to leave this and this. So what remains? 1 3 3 minus 4. So after solving you will get minus 13. A12 is equal to minus 1 raised to 1. This 1 plus 2 into minus 13. So this is odd. This is minus and this is minus. It will become plus 13. Now we will find minor of this. So this and this will go. And what remains? 1, 2, 3, 1. So its value is minus 5. So A13 is equal to minus 1 raised to 1 plus 3 into minus 5. This is even. So we will get value minus 5. Next we will find next minor of this. So this and this will go. What remains? Minus 1, 1, 1 minus 4. Its value is 3. Now we will find its cofactor. A21 is equal to minus 1 raised to 2 plus 1 into 3. Its value is minus 1. So minus 1 into 3 is minus 3. Now we will find cofactor minor of this. So this and this will go. See, this row and this column will go. That is 2, 1, 3 minus 4. Its value is minus 11. And we got cofactor minus 11. Now we will find M23. M23, write down the value of determinant, eliminate that row and column, and you will get the value 5. And this is odd, therefore it becomes minus 5. Now last row 3, 1. Don't take that row and column. So you will get that determinant minus 5. And A31 is equal to, this is even. So you will get cofactor minus 5. A32, 2, 1, 1, 3. That is 6 minus 1 is 5. Therefore A32 is equal to, this is odd. So this is minus and this is 5. That is minus 5. And M33 is, value is 5. And this is even. So the value remains 5. Now write down the cofactor matrix. So cofactor matrix is equal to minus 11, 13, minus 5, minus 3, minus 11, minus 5, minus 5, minus 5, 5. Now when you got cofactor matrix, write down the adjoint matrix. Take its transpose. Row will become column and columns will become row. So we got now adjoint. So now what is the formula for finding A inverse? A inverse is equal to 1 upon determinant value of A into adjoint of A. Therefore A inverse is equal to 1 upon minus 40. Our determinant value came minus 40 and this adjoint of a matrix. Now we will multiply that minus 1 upon 40 inside. So after multiplying we will get this minus 1 upon 40, take it inside. Now what is formula for X? X is equal to A inverse B. So A inverse into B. So this is our A inverse and our B is 1, 8, 1. Now this is the matrix of order 3 by 3 and this is the matrix of order 3 by 1. First write down the order of the multiplication matrix. So here 3 and 3 is same. So the new matrix will be 3 by 1. Means 3 rows and 1 column. So see here, row into column, row into column and row into column. So how you will do? 11 upon 40 into 1, 3 upon 40 into 8 and 5 upon 40 into 1. It will become first row. Then minus 30 upon 40 into 1 plus 11 upon 40 into 8 and 5 upon 40 into 1. Then third row, 5 upon 40 into 1, 5 upon 40 into 8 and minus 5 upon 40 into 1. Now do calculation. See, denominator is same, add the numerator. So you will get 11 plus 24 plus 5, that is 40 upon 40, 80 upon 40 and 40 upon 40. So that is 1, 2, 1. But our what is our x? X, y, z. So equate it. X is equal to 1, y is equal to 2 and z is equal to 1. Now this values of x, y, z substitute in any one of the equation and see that LHS is equal to RHS. So this is called as inversion method.